Hi guys, so this is section 5.3, and remember Mr. Hunt has videos posted for Unit 3, Test 3, and lecture videos. So I'm just doing these live homework. I'm working out the homework and talking and writing so you can see it. I don't know if that's helpful. I'm just putting it out there in case you need it. All right, so here we go. Okay, so section 5.3 is the derivative of logarithmic functions. Okay, so it's a derivative rule, okay, but it's not multiply down or subtract one. It's got its own rule, and here it is. So if y is equal to the ln, which is the natural log of a function, okay, so the f of x is the argument of the ln. It can't be separated, like that's not two different functions, that's one function. So if you have a function, the ln of a function, the derivative of the ln is the derivative of the argument over the argument, okay? So the derivative of an ln doesn't have an ln in it. It has the derivative of this over this. All right, so if you had y is equal to the ln of 5x plus 3, y prime is the derivative of 5x plus 3 over 5x plus 3, and stop. Okay, people sometimes try to cancel out these 5s, but you can't separate this 5x plus 3. It's polynomial. You can't undo polynomial. So that's a do not try to simplify. It's the derivative over the function. Even when you can simplify, I think it's just easier not to. So if y is equal to 3 times the ln of x to the 4th, well, remember the derivative, you just bring along the constant term times the derivative of the variable term. So if I have the ln of x to the 4th, it's the derivative of x to the 4th over x to the 4th, and you can leave it just like that, okay? Hawks will take it, it'll be perfectly fine. It'll be really okay. Now, when Hawks gives you the answer, they'll say, okay, x cubed over x to the 4th, you subtract your exponents. 4 minus 3 is 1, it's bigger on top, so you're gonna have 1 left over on top, so it's gonna be 12 over x. And that's okay too, but like I said, you do not have to simplify. So let's do the homework, okay? All right, so here we go. All right, so the homework for 267, 5.3. Can y'all see that? I think it's easier to see if I write things down. So number 1 is y is equal to the ln of x. And this one happens a good bit in Math 268, okay? Well, let's remember our rule. So, and there's the only rule, and it's going to work for every function. If you have the ln of a function, the derivative is the derivative of whatever the argument of the ln is over this, okay? So just like we had, the ln of 5x plus 3 is the derivative of 5x plus 3 over 5x plus 3. Okay, all right, so the derivative of, I'm gonna turn my phone off. The derivative of the ln of x is what? It's the derivative of x over x. Okay, it's just 1 over x. So What if y is equal to the ln of 5x? Okay, so let's look at that. So y prime is what? The derivative of 5x over 5x. Okay, and Hawks will call that 1 over x, because if you cancel out the 5s, you get 1 over x. But these are the same, okay? So you do not have to simplify. You can totally put that in there. So derivative over the function, okay? So 22x plus the ln of x cubed. And they want to know y prime. So I have 22x plus the ln of x cubed. So if I have two functions added together, I just add their derivatives. So the derivative of 22x is 22 plus the derivative of the ln is what? It's the derivative of x cubed over x cubed. And I'm going to just go through these problems and not simplify, because that's how I work them and that's how I accept them. Okay, and Hawks will do it differently. Mathway will do it differently, but this is how I'll know it's your work. Okay, don't simplify. All right. First 3 problems. And then here's a wordy type problem, but it's really not. Let's see if you can see. It says a shop owner has determined that the profit from the sale of X desks is given by this function. So my function is 33x plus the ln of x to the 4th plus 14, okay? Find the marginal profit function. Well, what does marginal profit function mean? Marginal profit just means what? Take the derivative. So the derivative of 33x is 33 plus the derivative of the ln of x to the 4th over 14 plus 14. And when you type these in, remember to do your fraction bar first, because once you start typing, you can't make a fraction bar. So it's the derivative for x cubed over x to the 4th plus 14. And remember, this will not simplify because you can't separate this polynomial. So when you have an ln, it's the derivative over the function. Okay, all right. So now find the derivative of the expression. Let me write this on a different sheet of paper. 21x squared times the ln of x. Okay, let me go back to something I was working just a minute ago. Here. Well, I can't find it. I got so much stuff. Okay, I can't find it. So remember, if y was 3 times the ln of x to the 4th, we just brought the constant term along and took the derivative of the ln. So it was 3 times 4x cubed over x to the 4th. And we said we can leave it just like that. Okay. So it was a constant in front of the ln, and I just brought it along. Remember, Hawks simplifies, but we don't have to. Okay, but now we're in a situation where I have 21x squared times, so right there, that's times the ln of x. And when I have two functions multiplied together, we learned on the last test, then to take the derivative, we have to use the product rule. So f prime of x is the first function times the derivative of the second plus the second function times the derivative of the first. And I'm going to just go down here and say, what's my first function? What's 21x squared? And what's the derivative of my first function? 42x. And my second function is the ln of x. And what's the derivative of my second function? Remember, the derivative of an ln doesn't have an ln in it. So the derivative of the ln of x is the derivative of x over x. So I have everything I need to put into my formula, and I'm not going to simplify it. So it's my first function times the derivative of my second plus the second function times the derivative of my first. Okay, and I am just going to leave it alone. Will it simplify? Yes. Hawks, we'll call that 21x plus 42x ln of x, but you don't have to do that. This is perfectly fine. Okay. All right, we've never simplified the product rule. No need to start now. Okay. All right, so let's look at question. That was question number 5. Let's look at question number 6. All right. 1, 2, 3. What was question number 4? Oh, that was question number 4. The wordy type problem about that. Okay. So that was question number 4. I worked it on here. It was given the profit function, find the marginal profit. So we took the derivative of 33x, which was 33. We took the plus, so we just add the derivatives. It was the derivative 4x cubed over x to the 4 plus 14. Okay. All right. So we did 5, and now we're going to do 6. So f of x is the ln of 19x squared minus 24x to the 4th power. Okay. All right. So it's a ln of a function, right? What's my rule? What's my rule say? Let's don't get crazy here. If you have an ln of a function, you take the derivative of your function and stick it over your function. Okay. So f prime of x is going to be the derivative over the function. And how do I take the derivative of a quantity to a power? I'm going to have to use the chain rule up here. So f prime of x is the derivative of my function over my function. So the chain rule, I multiply down times the inside minus 1 times the derivative of the inside. So 19 times 2 is 38, and I doubt myself, so I'll check it. Yeah, 38x minus 24. Okay, and you're good. Remember on these to make your fraction bar first. Okay, now, and this is fine. You can type it in like this. It might be easier if you do, the only simplification I would do is that if I have 4 down here and 3 of the same thing up here, that just leaves me what? 19x squared minus 24x times 38x minus 24. Sometimes it's easier just to simplify. I have this down here, the exact same quantity, and I just subtracted my exponents, which leaves me 1 at the bottom. Or not, leave it like this. This is perfectly fine. It's up to you. Okay. We're going to do one more of those examples. So that's missed a lot. People try to multiply down and include the ln, but remember, if you have the derivative of the ln of a function, it's the derivative over the function. So the ln, the derivative of an ln doesn't have an ln in it. We had an ln in one of them. Which one was it? Right here. Okay, because we had 21x squared times the ln of x. So it was the first function times the derivative of the second plus the second function, just like it is. So that's not the derivative. That's why we had an ln there, okay? It's not the derivative of the ln. It was just the second function. So anyway, just so you know. So if we have the ln of 5x cubed plus 7x, 5x squared plus 7x, to the 1/2 power, okay? That looks uglier, but remember, it's just the derivative rule. So f prime of x is going to be the derivative of this over this. So that's the chain rule. So f prime of x, I go ahead and make my fraction bar, and I usually just put my function, the argument of the ln, on the bottom, and it's the derivative. So it's 1/2 times 5x squared plus 7x minus 1, 1/2 minus 1, times the derivative of the inside, 10x plus 7. So just leave it alone. Okay, don't make it harder than it has to be. Okay, multiply down. But the people want to go 1/2 ln. So remember, if you have the ln of a function, the derivative doesn't have the ln in it. Okay, all right. And last but not least is f of x is 4x cubed over the ln of x to the 5th power. Okay, so what rule do we use? We used it on the last test. If I have a quotient, 4x cubed over the ln of x to the 5th, the derivative is going to be the quotient rule. And what's the quotient rule? It's the low function times the derivative of the high minus the high function times the derivative of the low, all over the low function squared. Okay, so my high function is what? 4x cubed. It's the one on top. What's the derivative of the high function? Okay, and my low function is the one on the bottom, the ln of x to the 5th. So what's the derivative of the low function? The derivative of the ln of a function is what? The derivative over the function, and I'm not simplifying. Okay, so when I put this in, I'm going to do my low function squared, and I'm just doing the low function times the derivative of the high minus the high function, low d high. So here should have gone what? 12x squared. Low d high minus the high function times the derivative of the low. And I know that's ugly, and I'm sorry I messed that up, but that's just low D high minus the high function times the derivative of the low. So just leave it like that. Even though it's ugly, just leave it alone. Okay, and that's it. And you're all done with all the information on test 3. So get started, send me emails, let me know if you have questions, and talk to you soon.